This lesson is about the natural logarithmic function. Starting with part A, the definition for that is that f of x is equal to the log base e of x. Remember, that was the natural exponential function. Then that really is saying the same thing as doing ln, which is said natural log of x. In this case, x has to be greater than 0 for that to happen, and it's called the natural log. The natural logarithm. We're going to start by practicing how to evaluate this, mostly just using the calculator. So example number 1, if f of x equals the natural log of x, and x is equal to 2, x is equal to 0.3, and x is equal to -1, let's figure out some values there. Using our calculator, the natural log button is found towards the bottom of the screen, just a couple above the on key. So if I do natural log of 2, my value I should be getting is 0.693. Do the natural log of 0.3, I should be getting -1.204. We're always rounding to 3 decimal places. And if I do the natural log of -1, I get an error. Remember, the reason that happens is because I cannot have negatives. So there's no answer there. That will give you an error every time. Okay, we're going to learn about some properties of these natural logarithms. They're very similar to the properties we learned about for all logarithms. The first one is that the natural log of 1 is 0. Remember, because that'd be like base e to the 0 power is 1. So if that's true, it's because e to the 0 is 1. Okay, the natural log of e equals 1. Think of that because e to the first power is just e. Okay. Also, you could think of it as these two are canceling each other out. The third property is the natural log of e to the x is equal to x, because e to the x is e to the x, or natural log and e cancel each other, so x equals x. And then the final property is that if the natural log of x equals the natural log of y, then x equals y. We'll use those properties to solve. Example number 2. E to the natural log of 5 is just 5. These two cancel each other. Example 3. Natural log of 1 over 3 equals 0 over 3, because the natural log of 1 is 0 from this property here. So 0 over 3 is 0. That's our answer there. Example 4. 2 natural log of e is just equal to 2, because natural log and e cancel each other. Okay, part B for today is for us to discuss one of the applications of this, and in particular we're talking about the human memory model, or our capability as humans to remember things, and the test that goes along with that. Now, this test is used for a variety of things, including things like determining whether people have Alzheimer's or if they are having true memory loss. So that's what these people were studying when they did this. I'm going to read to you the example. I'm not going to write out all of the details. I will give you the function and what pieces we're trying to look for. So the example is that students are participating in a psychology experiment, attend several lectures on a subject, and were given an exam. Every month for a year after the exam, the students were retested to see how much material they remembered. The model for the scores is shown by this function, which is f of t, the function over time, equals 75 minus 6 natural log of t minus 1. I'm sorry, that should be plus 1. Between 0 and 12 months, so time is 0 to 12. Where the time is t in months. The first thing we want to figure out is what was the average score on the exam at time equals 0. So right after they were given the lecture, what was the average score? To find that, we're going to plug in 0 for our time. And if we do that, we have 75 minus 6 natural log of 1. And remember, natural log of 1 is 0, so 0 times 6 is 0. 75 minus 0 is 75. Or you could just put that in your calculator. So the average score at the beginning was a 75. The next question we want to ask is, what is the average score at time equals 2 months and time equals 6 months? So 2 months after they were given the lecture and 6 months after. To find that, we're simply going to plug it in to our function and then use our calculator to solve. After 2 months, the average score was a 68. We're just going to round exactly up or down to a score. And after 6 months, let's see what that one does. After 6 months, the average score was a 63. So these people did retain actually quite a bit of information. And that's just one of the examples of a time when you would use the natural log. The assignment for this one is A5, and it's page 237, numbers 62 to 68 even, and numbers 89 and 90. I believe 62 to 68 are just solving or evaluating using the calculator and the properties, and the last two are application problems.